Hi, I'm Paul Bunn, Principal Consultant for Data, AI and IoT at Insight. Now more than ever, with COVID-19, has efficient remote collaboration between software engineers been as topical. Software projects that involve machine learning add an extra level of complexity as multiple disciplines are brought together. Data scientists and software engineers, and you are no longer just collaborating around software code artifacts, but also collaborating remotely around the data science processes involved in implementing predictive models, all the way from exploratory data analysis right through experimentation and ultimately releasing to production. Machine learning operations, or MLOps, is the bringing together of the DevOps core principles of continuous integration, observability, and high software quality practices, and the world of data scientists and applied AI engineers to ensure that machine learning solutions are delivered in a reliable and sustainable form into an organization's production environment. Now, as more of these cross-functional engineering teams are working remotely, often separated by vast time zones, the use of modern cloud-based technologies to facilitate collaboration at not only a code or software engineering level, but also across the exploratory data analysis and experimentation processes is a key feature that we have found separates a typical software engineering project from a software engineering project that involves machine learning. At Insight, we have experienced that access to data to support exploratory data analysis and feature engineering activities, and model lifecycle management, which is the tracking and managing of a model and its artifacts from experimentation to production and beyond, are of importance to remote teams working on machine learning problems. And these are capabilities offered by the Azure Cloud Platform through the use of Azure Data Services and Azure Machine Learning. These services are underpinned by access to scalable, cost-effective compute and storage resources, source code collaboration tools, automation of continuous integration, release, model performance monitoring and retraining processes, and finally, good governance and security. At Insight, we have noticed that data scientists often face challenges when it comes to getting access to data with which to explore a particular problem space further. Data is sometimes locked away in proprietary, sometimes on-premise systems, and data scientists usually have to rely on other teams or individuals in that organization to facilitate data extracts for them. This challenge is amplified now with teams working remotely. Our experience has shown that organizations can leverage the Azure platform to ensure that data is surfaced in an Azure-based data lake so that remote engineering and data science teams can get to the data they require in a secure manner, and this data is kept fresh automatically. The tools and technologies under the Azure Machine Learning banner can help facilitate collaboration between remote data scientists and software engineers throughout the development and operational lifecycle of a typical machine learning solution. All accessible securely via the internet, Azure Machine Learning offers tools for managing training data sets with tight integration with the Azure Data Services platform, model experimentation and performance tracking, data drift detection, which can be used as a trigger to initiate manual and automated retraining of models, notebook interfaces, which help teams collaborate remotely on problems, the ability to develop and test locally or utilize cloud compute resources without much more than configuration changes. And this is all brought together through tight integration with Visual Studio and VSCode. GitHub can be used for source code collaboration, and CI/CD tools like GitHub Actions or Azure DevOps pipelines can be used to automate continuous integration processes, which we have found helps remove operational friction with teams that are now working remotely and often communicating asynchronously due to being in different time zones or even personal commitments now that they're working from home. Build time issues are surfaced sooner rather than later, and communication is facilitated through integration with Microsoft Teams. Of course, security, governance, and protection of sensitive and personal identifiable information is paramount in a world where engineering teams are working remotely, potentially on devices that are not necessarily always running within the confines of your corporate network. Azure-based solutions can be architected to ensure that data is cleansed of personally identifiable information, and that sufficient controls are put in place to ensure that data doesn't need to and can't leave the confines of your Azure environment. Thanks for joining me. I hope you found that this illustration of how Azure can help facilitate collaboration and MLOps with your remote engineering teams helpful. Please don't hesitate to reach out to us at Insight if you would like to help enable your remote machine learning operations.